Data processing functions can be automatically performed on newly acquired data or on a previously saved spectra. To specify the data processing parameters, click the Parameters icon in the Processing menu or go to Processing Parameters. The Data Processing Parameter menu box will now pop up. You can select any function in the available items list to be added to the current items list by selecting the function and clicking Add. If you wish to delete a function from the current items list, select that function and click Delete. If more than one item is on the current items list, the order of operations can be switched by toggling between the up and down arrows. The following 19 processing functions can be performed for a measured spectrum, and they are categorized by correction, result, and data. The correction and result options, which are marked with a C and an R respectively, can only be selected once, while the data options, marked with a D, can be selected multiple times. The noise elimination option eliminates any artifact peaks that are a result of noise. By selecting the noise elimination option and placing it into the current items list and selecting the settings button, multiple wavelength ranges can be specified to eliminate the desired peaks. Smoothing specifies the parameters for smoothing the spectrum and reducing the apparent noise with 4 different smoothing methods available. The convolution width sets the number of data points to amass together during the smoothing process. Noise deviations enters the threshold noise variance when adaptive smoothing is selected, and iterations enters the number of times to apply the weighted averaging using the binomial smoothing method. When the arithmetic option is selected, it performs an arithmetic operation on the current spectrum or between spectra using constants. When a reference set is selected, the desired arithmetic operator can be selected from the drop-down list and constants entered into the appropriate boxes. The derivatives function specifies the parameters for differentiating a spectrum using first, second, third, or fourth order derivative calculations in one of 2 algorithms. Data points specifies the data interval between the data points, which essentially acts as a smoothing function. The K to M transformation converts a diffuse reflectance spectrum into an absorbance spectrum using the Kubelka-Munk model. XY unit conversion can convert the x-axis to the following units: wavelength, wave number, energy, or frequency. A spectrum having a defined data interval with a specified x-axis range can be interpolated using either the third-order spline or Lagrange methods, and specifying the data interval and wavelength range. The wavelength or x-axis range can also be cut using this interpolation function by selecting No Correction and specifying the desired wavelength range. The relative reflectance correction converts a relative reflectance spectrum to an absolute reflectance spectrum using a reference spectrum. The photometric value function is the only function that is not also available in spectra analysis for data processing. If photometric value is selected in spectra measurement for data processing, it will not be displayed if the spectrum is opened in spectra analysis. Photometric value displays the photometric values as specific wavelengths for up to 20 wavelengths. By double-clicking on Pass-Fail, the dialog box pops up to specify the criteria for a pass-fail evaluation. This option passes a photometric value not less than the value entered in the first text box, or greater than the value entered in the second text box. This passes a photometric value less than or equal to the value entered in the text box, while this option passes a photometric value greater than or equal to the value entered in the text box. This option passes a photometric value less than the value entered, and this passes if the photometric value is greater than the value entered in the text box. The pass-fail string specifies the text to be displayed if the photometric value passes or fails. peak find specifies the parameters for detecting up to 20 peaks. Top detects peaks, bottom detects valleys, and both will detect both peaks and valleys. The noise level determines a threshold used to recognize the top and or bottom of a peak. Upper and lower limit specifies the upper and lower limits for the photometric values for valid peaks. The number of peaks you wish to detect can be entered in the maximum number of peaks text box. Format selects the number of decimal places to be displayed in the graph and result list. Peak height calculates the height of a single peak or the ratio of the heights of two different peaks. 4 calculation methods are available and the peak wavelengths can be specified. If the peak height ratio option is selected, the second peak information must be specified as well. Format selects the number of decimal places to be displayed in the results list. The pass-fail criteria can also be set by clicking the Settings button. Peak area calculates the area of a single peak or the ratio of the areas of two different peaks. The methods for calculating the peak area and the baseline and the corresponding wavelength ranges can be specified for either 1 or 2 peaks. Pass-fail criteria can also be specified by clicking the Settings button. FWHM calculates the full width at the half maximum value of a peak. The wavelength range for the calculation must be specified and a pass-fail evaluation can be performed. Data comparison compares the measured spectrum with reference spectra to distinguish differences between the two. Up to 20 spectra can be compared in the result list. First, select the reference files for comparison. You can choose either individual files or an entire folder. The wavelength range to be compared can also be specified by selecting Range. Ten algorithms are available, and if Euclidean distance or first derivative Euclidean distance is selected, the values can be normalized. The closer the value is to 1, the higher the similarity to the comparison file. When the folder option is selected, the column number of comparison results displayed in the Results List tab can be specified. The number of decimal places can be chosen using the Format button, and a pass-fail evaluation can also be performed. Simple quantitation calculates sample concentration by performing arithmetic operations on the peak height or peak area using the specified values. There are 3 quantitation methods: 1 peak, which determines the peak height using a single wavelength; 2 peak ratio, which determines the peak height using the ratio of 2 peaks; and 1 peak thickness, which calculates the peak height or area and corrects for the sample thickness. The quantitation equation is then chosen from proportional, linear, or quadratic, and the slope and the y-intercept from a previously determined calibration model are specified. The concentration units must then be selected along with the number of decimal places to be displayed. A pass-fail evaluation can also be performed. The calculation method for finding the peak height or area is then determined. 4 methods are available for peak height and 3 for peak area. You can choose to use no baseline, a 1-point baseline, or a 2-point baseline. Enter the required peak and baseline wavelengths for the corresponding quantitation and calculation methods chosen. If a value is entered to the right of the plus-minus sign, the lowest absorbance value within the entered wavelength range is automatically determined. If average is selected for the baseline wavelength, the average absorbance value within the baseline calculation range is used as the baseline value. Up to 5 quantitation methods can be added and named. Film thickness calculates the film thickness from an interference pattern in a transmittance or reflectance spectrum. the incidence angle, sample refractive index, noise level for peak detection, and wavelength range must be entered. Format specifies the number of decimal places to be displayed, and a pass-fail evaluation can also be performed. The Autosave function allows you to automatically save your data by specifying the folder to save it in, as well as the format. Data can also be automatically exported as either a JCamp, ASCII, CSV, or XY ASCII file. Auto-transfer automatically transfers data after the measurement to Spectra analysis. Auto-print specifies the parameters for automatically printing after measurement and data processing, and the Save Result List automatically saves the result list in the specified folder, format, and is either a text or CSV file. Again, all the processing functions marked with a D can be used multiple times. If the photometric value, peak height, peak area, full width half maximum, simple quantitation, or film thickness processes are performed, statistical analysis such as average, standard deviation, and coefficient of variation can be obtained for a specified number of measurements. To open a previously obtained spectrum and view the data processing results, click the Open Spectra icon in the menu toolbar. If any processing was done on the open spectra, to view these results, go to View, View Calculation Information, select Display Calculation Results and what you would like to display, and then select OK. The results will then display under the Spectrum window in the Results List tab.